middle.
Play. Number one, but we're going.
Okay. This is the Glen Rose Formation, the limestone. This is the lower Aquiclude. That's the lower unit that confines the aquifer. Remember, the upper unit is that Del Rio clay. So this is the Glen Rose. Its age is about 111 million years. It's Cretaceous in age. Age date, 111 million. This unit was being deposited as one of the early units in that mid-Cretaceous interior sea. Remember, we showed that you had a seaway from the Gulf of Mexico all the way up to the Arctic, and essentially burying all of the area which is the present-day Rocky Mountains. So this is one of the early formations being deposited. Once the water got deeper, then we had the Edwards group deposited. So the Edwards is forming most of the time in deeper water. You can see where Jill is standing that the rock is very friable, it breaks easily, and then you get the more resistant layer above. The stuff that breaks easily, this is forming within fairly shallow water. We have a lot of bioturbation. Critters are digging through the mud. So you don't see much in the way of any layering. The more defined limestone above, you can see the layers, and that's deeper water material. You are finding the majority of the fossils within the more friable material below. If we had success, we'll be able to get good connection.
Yes.
See, and you have no chert. The moment you get into the next unit above, then you'll be getting into chert. So there's no chert in here. And you notice these alternating soft and hard zones. This is characteristic of the Glen Rose. This produces what we call a stair-step topography, where the finer grain, the mud-looking material weathers out faster than more resistant hard layers. So you end up with a variation in the weathering ability. And that's very characteristic as you drive north. Look at the slopes and you will see that also when you look at some of those slopes, some of them look like little dunce caps or a wizard cap coming up. And you see the stair step on the side, and then there's a layer on the top, and that's Edwards on the very top. If you were to climb that slope, the moment you got into that top layer, you'd find the chert. A real nice chert at the top layer. In fact, the Edwards at the very top tends to act like a protective cap, keeping the whole thing from just eroding away quickly.
Why is there no chert here?
Because the Edwards is characteristic of the chert. You have no silica solutions that are moving through this rock.
So even though we do find spicules and things like that, it's just not enough to actually produce a...
Right.
Okay. Dr. Free, what was the layering called? The hard and soft? The hard material and the soft material?
The layering?
Stair step topography.
What?
Stair step
Stair
topography.
step. Thank you.
We all got notes on this?
Yes.
Now, you're going to see the Glen Rose when you're in the cave. In fact, the bulk of the deeper area that you'll be in is all the very uppermost part of the Glen Rose. This, we're in the lower portion of the Glen Rose here, and this is a better aquifer. Now, what we're going to do is go up 281 a short distance and make a U-turn. There's a little place where you can make a left turn, make a U-turn.
We'll find it later.
Make a U-turn, and then come back, and now you can get on 46. Okay. And we're going to take 46 to east. We'll go east. And you'll see a marker, it was at 3009, I think it's hard to market, Ranch Road, 3009, it's in your lineup. And there's a sign there saying the Natural Bridge Caverns, and then we'll take a right, that'll take us into the caverns. Once